Hello everyone. In today's lecture, we are going to talk about Lakehouse. So what we'll do is we'll start with what is a lake house and what are its advantages. Why do organizations, right, in today's times have started adopting lake house as one of their architecture patterns? So let's get started. So previously, right, those who have worked on data warehousing world or data lake world, right, they may understand, right, there were some limitations and challenges of those kinds of ecosystems. Maybe first we'll have a look at that quickly, and then we'll move to Lakehouse. So since last couple of decades, right, people have been building data warehouse, right. Now, data warehouse was the solution for all your analytical kind of a workloads where you are trying to do OLAP kind of a use cases, mainly from BI perspective, right? When you wanted to build some dashboards, right? Dashboards or reporting solutions. Now, reports could be anything, right? It can be your MIS reports, it can be your regulatory or compliance reports, right? So this was the major use case. So that's where people started building a warehouse. Now, what's a warehouse? It's an integrated platform. If you go by the bookish definition, right, it's a subject oriented, time variant, non volatile data, right, that resides in your storage, which is nothing but a database kind of a storage which follows the acid properties, right, and you'll get some good performance to get the data out of that. So that was your typical warehouse. But the major right limitation of a warehouse was, let me just change the pen color. The major limitation here was, right, this was only for your structured data, right. Now this was good till maybe the 2005 2010, right, but since Hadoop started coming into picture, right, people started building what we now call as a data lake, right. People started building something called as the data lakes. Again, those who have worked on this, they would know it better. What was data lake was to store your unstructured data. Sorry, I just skipped the slide. Yeah. So data lake was for storing your unstructured data. It was mainly for unstructured data. What is unstructured data? Data that comes in forms of, let's say, your click streams, right? Or even your IoT sensors data, the logs from the various servers, right? So all these are unstructured data. Or maybe the most popular one is the comments from social media, right? Comments on Insta, YouTube, or your Twitter tweets, right? All this is unstructured data. So to store this, people started using data lake. Now data lake that time with Hadoop, right, it was built on something like HDFS, right, the Hadoop distributed file system. Nowadays we are building it using the cloud storages like S3. If you are into AWS, if you are into Azure, it is ADLS, right. Google has the Google cloud storage. So we started using data lakes and dumping all the unstructured data here so that it can support use cases like AI ML use cases, right? So now we moved from warehouse to a data lake. People started using data lake, but then like the warehouse, it also had some limitations. What it was, right? Performance was a bit of a problem because see, in warehouse, right, the warehouse are structured that way. It is all column storage and it has those specific, right, database kind of a features. You can do partitioning, indexing and all, so performance was better. But here in data lake, performance was one of the issues. Second is you cannot really do updates on the data on a data lake. It does not support acid kind of a features, right, so it has its own limitations also. Okay, so these are primarily being, right, the two types of storages used in the analytical world. First we started with warehouses, then we started with data lake. Now because both of them were there were some disadvantages, right, for both of them. So we finally started building something which had both of these, right. There was a warehouse plus there is a data lake. Okay, so how this helped is, right, you will have all your let's say your structured data in your warehouse, and all your unstructured data would get into your data lake. How it helped, um, for your any BI kind of a workloads, okay, you would be using DWH and all. For any AI ML kind of a workload, right, you will use your data lake. So you get, best of both the worlds. You also have the data lake, you also have the warehouse. um, Warehouse gives you the features like acid and performance, which is needed for generating insights, dashboards, and reports. And data lakes give you the scalability, because unstructured data, it's a very, very large volume of data. It gives you that scalability plus economies of scale. The cost is very, very less, because you would be using cloud storages and all. So these were much cheaper as compared to the warehouse. So you got best of both the worlds. And then this architecture, right, became very, very, um, popular in last few years. But then, like any other architecture, right, it also has some kind of limitations. Now, what are the limitations of this architecture? uh, one thing that you can easily identify, since you are storing the data at two places, right? You are storing the data in BI, you are storing the data, sorry, you are storing the data in warehouse, you are storing the data in the data lake. So there was a certain kind of a data movement, right, or data copying. Okay, so you have to copy the data from data lake to warehouse. So there was no single source of truth, right? No single source of truth, because you are storing the data at two places. And there were a lot of manual efforts, right, to move this data every time. Okay, or manual efforts, or you can say you need to write a code for that, but it was a time consuming task. So one is you have to copy the data, second is you always have to keep that in sync. Because of that, there is no single source of truth, and this causes a lot of error many times, right? It's not easy to maintain the data. Sometimes, right, you may have to delete something. Okay, let's say you're working on GDPR kind of compliance things, where you have the right to forget and you want to delete something. Now you'll just delete the data in warehouse, but from lake it is not easy, right? It does not have update or delete kind of a features. You have to drop the whole partition, so a lot of things are required there. So again, if you have done some deletes in warehouse to reflect that in data lake, it was not easy. So all these issues are still there. I mean, this architecture work fine, but then there are these kind of limitations. Plus the other disadvantage I feel is, right, for it is specific to your workload, right, from where you have to get the data. So if a user is trying to get BI reports, they have to go to a warehouse. If someone is trying to get AIML, it has to go to the data lake. So again, for user, right, it is not an easy option, because they'll always have to know like where my data resides and how do I need to query that. Maybe again a federation layer on top of these might help, right, to get the data directly without understanding where it is. Now, because of these limitations and all, since maybe last year, right, or a couple of years back, a new concept has started, being discussed a lot. I won't say it's a new concept now, because people have already started using these. This is called as a lake house. Okay, and as the name suggests, right, you will have the advantages of both, of a data lake as well as a warehouse. Okay, both of them. How would that work? So basically, you are creating a lake plus a warehouse, right? This was the previous architecture, but here it's not like that. Okay, you are not creating a separate lake and a warehouse. So what happens in a lake house is nothing but primarily just a lake. Okay, it is just a lake, and there is no warehouse. Okay, warehouse is not there. So let me show it this way. So there is no warehouse. Okay, remember this. When you come to a lake house kind of architecture, it's just a lake and there is no warehouse. So if you remember, right, with lake there were some issues, right? There were some limitations. So what were the limitations? Like, um, acid features were not there, right? Performance was an issue. Okay, you cannot really do the updates or deletes. Okay, on the data lake. It was only meant for unstructured data, not for structured data. So with Lakehouse, right now what happens is, um, you have the data on the data lake itself. It can be S3, ADLS, Google Cloud Storage, and then you try to bring in these features, right? Okay, so that it can support ACID features. It can give you a better performance. You can have the column level security and all. You can see the data in a tabular form, right? So how these features are used? So there is something called as the open table formats, I would say. Many people call have different names to it. There's something called as open table formats. Okay, now what is open table format, or even the storage frameworks, right? So what it is, there is a metadata layer on top of the data lake. So let's see, this lake is nothing but a parquet file. Okay, what you will do, you will create a metadata layer on top of it. Okay, so the data would reside in the Parquet, and the metadata would reside, right, the table schema on this layer. Now this layer is how we bring this layer is using the open table formats. Now in today's times, right, there are in fact three open table formats which are very popular. Okay, which are these? The first I would say is the Delta format. Second is Apache Hudi, and the third is Apache Iceberg. Okay, now these are all open source, while Hudi and Iceberg are Apache projects. Delta is an Linux Foundation one. Databricks is the one who had coined the term Lakehouse. They started with the Delta format, and then they and I think they open sourced it with Linux Foundation. And now recently, right, in last couple of months back during the summit, they have announced that the whole complete Delta, right, will be open source now. So all the features which are available within Delta with Databricks would be available with the open source version also. So due to this open table formats, right, you get these features, right, like just a minute, yeah, these features of having ACID, plus the ability to do updates and deletes using these open table format, because you get the metadata layer on top of it. Now we'll have to do a more deep dive, right? Maybe in some of the other lectures we can do that, how actually Delta works, or Hudi works, or Iceberg works. How does they handle the updates and deletes when you have this data on top of this. But for this lecture, we'll just restrict our discussion to how does the lake house work, right? Now if you understand lake house, it's lake plus there is no warehouse, but the lake itself gets the feature. So you try to understand it this way, right? So lake house is not a lake plus actual warehouse, it is a lake plus the features of a warehouse. And how do we get these features? By using these open table formats called like the Delta, Hudi, and Iceberg. Now what are the advantages, right? So whatever we saw earlier, okay, which were not the limitations of a lake, how of a data lake or a warehouse, or a data lake plus warehouse kind of an implementation. So what happens with lake house? What all things do you get? Right, first is it's a single version of truth, right? Single version of truth. Why? Because you are not maintaining the data at two places, right? The data is only into the data lake, right? You don't have to move it anywhere else. Okay, so single version of it, no copying, right? You don't have to copy the data, no copying of data from the data lake to the warehouse, right? So all those efforts and manual efforts are saved. You don't have to sync the data, right? You don't have to spend any efforts in doing all these things. Then the other advantages as compared to just data lake is you get the ACID features. You can do updates and deletes and easily. You get all the features, like you can do a column level security kind of thing. So if you want to hide a particular column from a particular user, that becomes possible because there is a metadata on top of it, right? And then finally, it's since this is all open source kind of a thing, it's not proprietary, right? See the previous warehouses, that you would have worked on, right? We have to move the data into the warehouse, and to get the data out of the warehouse, right, you have to use the warehouse compute. Okay, that is what's this is a very important concept that you need to understand. So here, right, the storage and compute is separate. So you're storing the data into the data lake in the form of, let's say, parquet file. But to fetch the data, the compute that you are using, right, you are free to use any compute. You can use Spark, you can use Presto or anything. So there is no proprietary kind of storage there, and you don't have to use the same storage or the same the compute provided by the same warehouse, right? In the previous times, whatever goes into a warehouse, you have to get that using the warehouse's compute, right? That doesn't happen with the Lakehouse. So again, this also helps in your sharing the data, right? If you want to share it with anyone, it becomes much easier, right? So the final consumer, right, the data consumer, they may not have the same compute that you are using. Okay, let's say you did this into data bricks, okay, and you have written the data into an S3 or ADLS. So someone who can be given the access to that particular S3 bucket, and then they can use even things like Athena to query that, and they can use open source Presto or Trino or just even Spark, right, to do that. So that data sharing also becomes much easier. So yeah, these are the advantages of of using a lakehouse. So just to quickly summarize, right, so what we have seen is, what's a lakehouse? Lakehouse is a primary data lake, but there is no warehouse. Okay, so data resides only on the data lake, but you have a metadata layer on top of it, which is called as open table format. If you come from the Hadoop world, visualize it with Hive perspective, right? Hive was very similar to this, where you had the metadata within the Hive metastore and data on HDFS, right? It's very similar to that. So Lakehouse would be just the data lake without the actual physical warehouse, but then you have a open table format on top of it, which gives you the features of a warehouse. So you get the asset features, you get also the time travel features, if you are aware of, right? You get those, plus you don't have to sync the data, you don't have to copy the data from one place to other. So the most important advantage is the data resides at a single place, you get a single source of truth, and it becomes easy to implement the the warehousing kind of a features on this using the open table formats. And finally, it would help you for getting more flexibility and freedom, how you want to share the data, how you want to query the data, how you want to access the data which is within a lakehouse. So yeah, that's it for the day. We'll continue this discussions in our further lectures. Thank you so much for watching this video.